First came the wobble, a half pixel here, a half pixel there. Then the path of 3I Atlas refused to stay put. For an object flying in from interstellar space, the rules should be simple. Gravity takes the lead, and the math holds. But the trajectory wasn't obeying the numbers. Predictions that had lined up cleanly the night before were off by morning. The curve bent. The residuals grew. Tiny at first, then undeniable. Here's why that matters. Interstellar visitors don't get a lot of chances to make mistakes. They rush past the sun once, maybe twice if fate intervenes, and they are gone. You plot, you predict, you watch. If the path shifts unexpectedly, something else is pushing. And if it's not gravity, it's a new story. Within hours, the coordination lights went green. The United States Space Agency, NASA, fed fresh astrometry into its navigation models. The European Space Agency, ESA's orbit team, ran an independent solution and didn't like what they saw. It diverged, slightly, but steadily. The Japan Aerospace Exploration Agency, JAXA's pipeline, flagged outliers and reprocessed every frame. The China National Space Administration, CNSA, released a brief note. Preliminary fits require non-gravitational terms. The message was subtle, but stark. The usual playbook wasn't enough. Ground telescopes pivoted. The Very Large Telescope, VLT, stretched exposures along the predicted direction of motion, looking for a faint coma that might explain outgassing thrust. The Atacama Large Millimeter/Submillimeter Array, ALMA, listened in the millimeter, hunting for the soft whisper of escaping molecules. The James Webb Space Telescope, JWST's team, discussed a target of opportunity, careful not to overpromise. Solar Orbiter, far from Earth's vantage, offered geometry, sunlight from a different angle, pressure from another side. And behind them all, the Interstellar Observation Array IOA came to life. A patchwork of observatories agreeing to act as one instrument, one clock, one shared sky. The first comparisons didn't agree. NASA's solution leaned toward a weak, steady push, like sunlight striking a thin body. ESA's model fit better with episodic thrust, as if jets were switching on and off. JAXA's re-reduction shaved the deviation down. Then CNSA's added it back. A war of decimals broke out. Which star catalog, which distortion map, which bias correction? The data was clean. The disagreement was not. Some saw a simple culprit, maybe a gravitational nudge, a quiet pass by a small body we just didn't see. Others pushed back. The numbers didn't match a tug, they matched a push. Outgassing could do it, but the VLT's images didn't show a classic tale. ALMA reported no obvious signatures yet. If the object was shedding, it was doing it in a way we weren't used to seeing. Think about that. An object from beyond our system, built for cold distances and dark space, arriving at the inner sun and breaking our models not with spectacle, but with precision. Not a firework. An equation that doesn't balance. The IOA stitched together a global plan. Cross-calibration runs. Simultaneous exposures to beat down systematics. Polarization tests queued, even before the spectroscopists got their first clean lines. Every agency agreed on one thing: stop arguing with hunches, let the photons decide. And yet the tension deepened. The latest pass tightened the orbital solution and widened the mystery. The deviation was real. Its sign and strength shifted with solar angle, but not quite as radiation pressure alone would predict. No dust halo, no obvious jets, and still a measurable push. A contradiction wrapped in perfect motion. The stakes rose beyond navigation. If 3I Atlas is being moved by forces we can't see, then its surface, its structure, or its chemistry may be unlike anything our system ever forged. That's more than a curiosity. That's a rewrite. So the teams prepared the next move. Break the light apart and read the fingerprints. Spectra would speak where the trajectory only hinted. And when those lines arrived, everything would tilt again. The lines arrived. They were wrong, and the color wasn't behaving. Here's why that matters. Spectra are the fingerprints of worlds. Shine a star through a comet, and the gases tell you exactly who they are. Water, carbon compounds, a predictable family reunion. 3I Atlas didn't show up to that reunion. The usual bands for water and cyanogen stayed quiet. Instead, sharp teeth rose in regions where nothing familiar lives, while broad shoulders where silicates should sing were flat and cold. The chemistry didn't line up with anything local. It didn't line up with anything at all. NASA's early readout called it volatile light and carbon dense, an object that reflects more than it exhales. ESA teams pushed back. If carbon were the culprit, the slope in the near-infrared should steepen. It didn't. JAXA flagged the red edge shifting with viewing angle, a move more like thin films than dust. Meanwhile, ALMA watched for the telltale breath of CO or CO2 and found whispers, not the loud, steady venting a sun-warmed traveler should show at this distance. A quiet body that shouldn't be quiet, growing brighter in colors it shouldn't own. Think about that. Then the Interstellar Observation Array went to work. The IOA's polarimetry, maps of how light twists after bouncing off a surface, laid out something no one expected. Islands of low polarization nested inside a more polarized sea. Hollow zones. Their contours matched the object's rotation like ribs inside a shell. The pattern didn't drift like gas. It held like structure. ESA's VLT confirmed a weird negative polarization branch at angles that normally favored dusty jets. No jets, just a shape-filtering sunlight like layered skin. That's when the language shifted. Engineered crept into private channels, not as an answer, but as a question scientists don't ask lightly. Could voids and layers be natural? Absolutely. Sintered crusts, collapsed caverns, fractal porosity. Nature is brilliant at building. But the scale here, the coherence of the hollows, the way the color index snapped with phase angle instead of distance from the sun, those are the kinds of details that make modelers stare at walls. The data conflicts tightened. CNSA's analysts released a preprint arguing for a thin shell scatterer. Think eggshell, not rock. NASA countered, the same signal could come from ultra-fluffy aggregates, cosmic dust packed looser than smoke. JAXA asked everyone to breathe and recalibrate. At these faint levels, a single offset can pretend to be a miracle. The IOA reprocessed everything with new flats. The features stayed. They didn't sharpen into certainty, but they refused to vanish. And that persistence is its own kind of alarm. Meanwhile, JWST's mid-infrared peak stole attention. The classic 10-micron silicate bump? Absent. In its place, a shallow plateau, like heat re-radiated through a thin, uniform layer. No crystalline spikes, no rough grain chorus. Smooth. Deliberately smooth. There's that word again, hovering at the edge of the screen. Deliberate. Scientists hate it until they can't avoid it. ESA asked for a halt on press statements. The story was running ahead of the statistics. NASA argued for more eyes, not fewer. Open the archives. Let everyone try to break this. The IOA became the symbolic middle ground, streaming polarization frames in near real time, while moderators fought to keep the comment threads civil. This wasn't just an object now. It was a test of how science holds together when the sky refuses to play by the rules. And then, another twist. 3I Atlas brightened by a fraction, but the spectral lines didn't deepen. The color shifted without the chemistry following. Surface physics over gas physics. A skin doing the work of a coma. If light alone could be shaped, if interior hollows could guide it, then we weren't just looking at composition. We were looking at design constraints, natural or otherwise. Agencies converged on a next step that cuts through argument. Don't infer layers, detect them. If hollows are real, a radio whisper should find the seams. Low-power radar, penetration scans, phase delay maps. the IOA spun up coordination with ground arrays and deep space assets, tuning for a pass where geometry and distance could favor a bounce. Because if the spectrum lies, the echo won't, and that echo would change everything. The echo came back wrong. Not one surface, not one depth. It split. Here's why that matters. A clean object gives a clean return. One bright spike, maybe two if there's a cavity. 3i Atlas sent back a staircase. Discrete delays, evenly spaced, as if radar waves were stepping through layers that shouldn't be there. The interstellar observation array pushed every dial it had, stitching together a bistatic pass from scattered assets. Low power, long integration, a map drawn in timing rather than light. When they inverted the data, a picture emerged. Nested shells, slabs, something stratified across kilometers. Think about that. Most comets are rubble with a frosting of ice, chaotic and porous. You can get layering from ancient accretion or slow baking near a star, but it's messy, tilted, uneven. This was tidy, regular, suspiciously organized. NASA posted the first delay Doppler plots to a private channel. Concentric bands, rotation aligned. ESA analysts pushed back within hours, cautioning about side lobes, processing ghosts, the cruel tricks of radar unfolding. CNSA ran a parallel reconstruction with their own filters and saw the same intervals, but with one twist. The layer spacing matched the object's light curve beat, measured earlier that week. JAXA called it a stacked interior with non-uniform dielectric constants, a phrase that said what everyone was thinking without saying it. Natural? Maybe. Neatly built? Maybe. And this is where everything shifted again. Instruments inside the IOA's chain began to fray. Not catastrophically, subtly. Noise floors rose during the closest approach of the radar beam. Timestamps jittered by milliseconds, then tens. Gains drifted. A few antennas threw thermal warnings as if something in the signal itself was pushing back. Proximity effects, the engineers wrote, as if naming the glitch could tame it. Data conflicts piled up. JWST, barred from radar, watched the heat. Its spectra hinted at low thermal inertia, fluffy on the outside, yet the radar implied rigid internal boundaries. VLT tracked the brightness variation and found a second harmonic creeping in, a wobble that shouldn't appear if the body were a simple top. ALMA pointed to the object's radio continuum and saw a flatness that suggested an unusually clean surface, or a surface that was doing something to the incoming waves. Solar Orbiter, skirting its own perilous path, logged a transient uptick in charged dust near the line of sight, but team leads warned, correlation is not causation. Here's the discomfort. Each instrument told a coherent story on its own. Together, they contradicted each other. Some researchers argued for a natural stack, like an onion layered by billions of years of freeze-thaw cycles, each shell sintered by cosmic rays. Others pointed to the regularity in the radar steps and saw design, an interior that looked like it had a purpose. And while the arguments sharpened, the IOA's receivers kept misbehaving in the object's direction. Engineers swapped clocks. They checked firmware. They rerouted power. The degradation subsided when the beam moved off target, then crept back when it returned. Now consider this. Mid-pass, the echo changed shape without any change in our transmission. The delays tightened, then loosened, as if the layers themselves were shifting. A rotation effect? Maybe. A processing artifact? Possible. Or a system responding. What can be trusted? The raw echo, the thermal map, the light curve, the network that delivers them? This is how a data crisis feels. Not a dramatic failure, but a swarm of tiny uncertainties nibbling at confidence until only doubt is left. Across agencies, the language softened and hardened in cycles. Preliminary, tentative, compelling. Private calls buzzed, public statements hedged. The IOA, our symbolic lifeline across continents, held the coalition together even as its own channels sputtered under the very phenomenon we were trying to understand. Beneath the static, though, the core anomaly remained. 3I Atlas wasn't a simple rock or a simple snowball. It had layers, and those layers behaved like they knew we were looking. So the teams did the only sensible thing. They widened the watch. If radar could be fooled, light might still tell the truth. New campaigns lined up to stare, uninterrupted, through the next approach. The next signal wouldn't be an echo. It would be something else entirely. It started as a flicker, then a second one, exactly on time. Not noise, not natural drift, a beat. Here's why that matters. Comets and asteroids brighten irregularly. Sunlight glints, dust vents, rotation modulates. They don't hold time like a metronome. But 3I Atlas did. The pulses arrived at fixed intervals, steady enough to set a clock by. That precision cut across every expectation, and it cut deep. Teams pulled up everything. The interstellar observation array pivoted to full sky coherence mode, knitting antennas across continents into one giant ear. NASA and ESA synced cadence scripts. CNSA pointed its deep space nets. JAXA called in high-cadence photometry. And then the strangest shift yet. When the IOA locked its observing windows, the pulses sharpened. The signal-to-noise rose as if the object favored the attention. Think about that. It wasn't just brightness. Spectrometers on the VLT saw microflashes with narrow color spreads that didn't match standard outgassing. JWST looked for heat and found brief temperature bumps confined to geometric patches already hinted at by earlier radar layers. ALMA scanned for gas to explain the activity and came up nearly empty. No broad plume, no rich molecule fog. If this was venting, it was the quietest, cleanest venting anyone had ever seen. And then, the fields answered. ESA's solar orbiter registered crisp magnetic jitters coinciding with the light peaks. Tiny, but real. On the ground, the data rooms grew louder. Some at NASA called it an instrument crosstalk echo, an observational artifact feeding back through aligned schedules. ESA pushed back. Independent magnetometers, same timing. CNSA, more direct, floated the word many were avoiding: deliberate. JAXA urged restraint. Electrostatic discharge on layered surfaces can self-organize, they said, especially if those layers are exotic. But those layers were the problem. Remember the earlier scans? Strata that looked engineered rather than sedimented? The new pulses mapped perfectly onto those bands. Light emerged in rings and bars, as if the object's own internal structure was guiding energy along planned paths. That correlation sent modeling teams into a sprint. If 3I Atlas were natural, something had tuned it in a way nature rarely does. If it weren't, then the term artifact wasn't hyperbole anymore. Data conflicts, already frayed, snapped into open argument. The IOA's composite showed timing stability to the millisecond. An independent ESA analysis claimed drift just above that, too messy for intention. JWST's thermal team argued the heat signatures were too weak to carry information. VLT photometry countered that information didn't need heat, only order. ALMA's null result on gas became a Rorschach test, proof of engineered emission to some, proof of overly optimistic instrumentation to others. And this is where everything shifted again. During a coordinated, uninterrupted stare, the pulses rose in amplitude each time a new array phase-locked to the watch. Pile on more eyes, get more signal. Turn a few away, it softened. It behaved like 3I Atlas could sense the coherence of our gaze. Not just light hitting it, attention itself, encoded as synchronized measurement. It could be physics, it could be design. Either way, it rewrote the room. Solar probes logged another wave of magnetic nicks. The timestamps aligned with IOA's master clock, not any known rotational period. That cut the last comfortable escape route. Rotation was out. Random volatility was out. What remained teetered between unnerving and historic. Across agencies, scientists accepted a new phrase out loud: controlled emission. The debate shifted from if to how. Waveguides inside layered material, piezoelectric discharge across vacuum-separated plates, some kind of resonant cavity built into a body that had crossed the dark for eons. Each explanation begged a larger question. Who would engineer a messenger that only sings when watched? So a decision formed in the tension. The models had run out of safe distance. The coalition greenlit what everyone had hoped to avoid and feared to delay: a close pass. A probe, retasked and already on a lucky vector, was nudged toward an intercept window. Risky, necessary. The IOA took a breath and held it, because if the pulses were an invitation, someone had to answer up close. The pass begins. Telemetry climbs. 3I Atlas fills the probe's sky. This is the closest look humanity has ever taken at an interstellar visitor that might not be natural. Here's why that matters. If the pulses back in deep space were deliberate, then the surface should tell the truth. Nature loves chaos and erosion. Engineering prefers intention. The first returns don't blink. Ultra-close LiDAR and grazing angle radar carve a relief map across a world the size of a small mountain. And the contours are not random. Ridges resolve into repeating lengths. Depressions stitch into tessellations. There are planes where there should be boulders, seams where there should be fractures. Not perfect rectangles, but patterns that argue with geology. NASA's flight room goes quiet, then erupts. ESA's operations team tags regions of interest and feeds new pointing to the probe. The Interstellar Observation Array, our global net of telescopes and stations, routes the fire hose of bits, archiving, mirroring, failing over. CNSA's deep space dish reports clean lock on the high-gain antenna, but sees a curious drift in carrier phase. JAXA's navigation analysts ping the IOA channel. Attitude control is fighting a tug it can't model. Ground-based eyes pile on. The VLT sees the object's brightness plateau instead of peaking, as if something is managing reflectivity. ALMA listens in the millimeter band and catches a sudden drop in the faint gases that had been whispering off the surface, outgassing that just stops. JWST can't point this close to the sun, but its team posts pre-pass infrared lines from days earlier. Whatever was warm then is different now. And that's when the meters go red. Solar Orbiter, sunward and watching, flags an impulse in the local magnetic field. A spike too sharp for solar wind alone. At the probe, magnetometers peg. Star trackers snow. A hum invades the comm loop, a ripple that looks like interference and feels like intent. Engineers call it a surge because the word is safer than what it looks like. A response. On the cameras, a skin blooms around 3I Atlas. Not dust, not a standard coma. A transient plasma shell, thin as a thought and bright like it knows how to glow. The color tilts to electric blue-green, emission bands sliding into places that laboratory plasmas only hit under control. The object wears its own atmosphere, then sheds it in sheets. Think about that. A body that has drifted for eons, building a halo on command. Data conflicts explode in the same moment we need consensus. One console says the glints are specular reflections off planar surfaces. Another calls them artifacts from the spike hitting the detector clocks. ESA's timing beacons insist the probe's clock slipped microseconds during the surge. NASA counters that the beacon timing could be compromised by the plasma. The IOA arbitration channel lights up with caveats. Files re-uploaded, calibrations reapplied. Everyone is right, and nobody agrees. CNSA forwards a spectrum where narrow lines wink on and off at harmonics of our own radar chirps. Feedback? Someone asks. JAXA suggests the surge may have scrambled the probe's transmitter, imprinting our pings onto the shell. Others whisper the more uncomfortable option. It was answering. There's more. The detailed map recovers before the link degrades, and it shows a lattice at one pole. interleaved plates, evenly spaced, half-buried. Geologists argue for freeze-thaw layering across many epochs. Engineers trace straight edges and count ratios. VLT reports a polarization swing that shouldn't be possible without aligned grains or surfaces. ALMA, stunned by the silence in volatiles, suggests that surface activity has been quenched, not exhausted. And then, as quickly as it started, the surge collapses. The shell unwinds into threads and vanishes into space. Magnetometers fall back into range. The pulses, gone. The object dims, resumes its outbound glide as if nothing ever happened. Screens across the IOA flash green again, but the maps don't agree. Some show the lattice crisp and real. Others show blur and jitter where the features should be. NASA asks for a blind review. ESA proposes a joint release with cautionary flags. CNSA withholds a subset pending verification. JAXA posts their attitude data and invites replicators. The argument spills into public, because how could it not? And this is where everything shifted again. We got the closest look, and it split the room. Next comes the reckoning, what the world thinks we actually saw. The reckoning doesn't arrive as a headline. It arrives as a flood of numbers, and they refuse to agree. Here's why that matters. After the closest pass, the data should have converged. Geometry pinned down. Material signatures cross-checked. If anything could end the argument, it was this. Instead, the object that brightened, pulsed, and wrapped itself in a transient plasma skin leaves us with two truths that cannot occupy the same sky. NASA's blind review comes back first. Yes to non-gravitational forces. No to standard outgassing. The acceleration curve is wrong for jets. ESA sticks to cautious flags. Statistically strong pulses, but the timing could alias with observing windows. CNSA releases the withheld subset. Their magnetometers show step-like transitions that land on the same minutes as the light pulses. JAXA posts a full replication package, attitude, calibration lamps, onboard clocks, inviting the world to break their pipeline. The IOA stitches it all together in a public ledger. Who looked, when they looked, how they looked. And this is where the story sharpens. JWST reprocesses near-infrared frames and finds no ordinary coma, no familiar ice bands, just a flat, stubborn spectrum where vibrational fingerprints ought to live. VLT polarimetry says the surface scatters light like interlocking plates, not dust. ALMA, straining at the noise floor, sees a whisper of non-thermal emission during the surge and then silence. Solar Orbiter reports local field spikes that arrive in sync with the IOA's highest signal-to-noise pulse train. Think about that. The timing aligns with our attention, not the sun's heating curve. Some call it deliberate behavior. Others call it the cruel magic of sampling, human schedules imprinting on a light curve. Underneath the debate sits a simple, unnerving picture. The layered lattice is real in multiple instruments. The pulses are real in multiple bands. The magnetic surge is real across independent platforms. What they mean fractures the room. One camp leans into engineering, a controlled emitter using its layered structure to store and dump charge, a beacon riding interstellar fields. Another constructs an exotic natural, a metastable composite born in another system. Microcavities charging like 1 billion tiny capacitors, releasing in waves when solar wind conditions cross a threshold. The interstellar observation array becomes both lab and courtroom. Teams rerun deconvolutions with swapped priors. Timestamps are reconciled to a common atomic clock. A hidden bias is found in one pipeline's flat field. A different bias appears in a rival's background subtraction. Curves shift, but the core anomaly holds. The object still refuses to be just a rock or just a comet. Agencies harden their positions. Press releases choose verbs carefully. Consistent with, incompatible with, cannot rule out. Review panels argue over what counts as evidence of intention. The geopolitical seam shows, and yet, through the noise, something larger takes shape. Here is the paradigm shift. Interstellar visitors can be active without being alive, structured without being built by hands we recognize, and influential on their own motion in ways our models never planned for. Our textbooks gain a new column. Our surveys add new triggers. Our spacecraft prepare for objects that may talk back in fields, not words. In the final analysis, 3I Atlas leaves more open than it closes. It forces a universe where natural and engineered aren't clean boxes, but overlapping sets on a diagram we're still drawing. It anchors a new class by being singular. It makes the IOA not just an array of instruments, but a symbol of how we will argue and learn in public, across agencies, across borders, across doubts. And then it goes, fading into the dark on a trajectory reshaped by forces we can describe, but not yet predict. Behind it, terabytes of disagreement and the first draft of a new rulebook. We didn't get closure. We got permission to ask bigger questions and a cosmos that just got larger.